Recovery 2.0 provides an opportunity to learn how to manage resources in a sustainable method by treating waste as a resource, while assisting with the world's demand for clean water and clean energy, using thermal reduction. In this video we will discuss the reality of carbon and the Recovery 2.0 innovative approach in dealing with carbon when processing residual wastes. The reality is, we live on a carbon-rich planet. The natural carbon cycle will proceed with or without the influence of mankind. It is incumbent on mankind to adopt a responsible practice for sustainable management, and to maintain an equilibrium of our environment. It seems that our legacy practices in regards to CO2 emissions has failed us, and a new strategy must be adopted to reverse the damages that mankind collectively has created. Mixed or common solid wastes consist largely of carbon or hydrocarbon-based materials. This includes all types of food waste, green organic wastes and sludges, all wood and paper products, plastics, rubber, and textiles. Many current projects are focused on the defossilization of the carbon cycle. The Recovery 2.0 efforts, however, are largely centered around, and result in, the sequestration of carbon dioxide through conversion into carbon and carbon products. The Recovery 2.0 approach would regenerate complex waste materials back into the simple elemental building blocks, in order to use waste as a resource and to capture value in strategic materials. The recovered elemental building blocks are used to reconstruct the circular resources that are required to build the future. Since the nature of the original source of the waste feedstocks are carbon, or hydrocarbon-based, the reality is that many of the end products produced from a resource recovery process are therefore, carbon or hydrocarbon-based. The recovery of carbon would provide the opportunity to produce any number of integrated carbon products. These include electrolytic carbon, filtration media, carbon powders, and pigments, and a wide range of fabricated carbon, graphite and graphene products. One of the most exciting untapped potentials is the production of clean carbon fuels, that may be a direct green substitute for coal. The adoption of closed-loop mass balance technologies, that eliminate combustion emissions to the atmosphere, may provide a virtually unlimited use case for any volume of carbon on a regenerating cycle. The production of a recovered solid carbon presents the potential to capture raw CO2 out of the environment and from emissions. The containment and conversion of CO2 into a variety of useful products is an integral component in a circular regeneration cycle. This approach is classified in three main areas. First, the regeneration and productive use of carbon and carbon products. Second, the conversion of CO2 into carbon-based chemicals and fuels. And third, the beneficial use of CO2 as an industrial working medium in a solid form or in the form of fluids, which can be gases or liquids. Recovery 2.0 was developed by Waste.net as a system to manage resources in a sustainable method by treating waste as a resource. If you would like more information about the Recovery 2.0 process, additional videos are available and links have been provided in the comments, or feel free to reach out to us. Waste.net is a tool to assist you by matching waste material generators directly with beneficial users of those materials. By connecting you with market participants, we foster collaboration and promote environmental sustainability. Visit our website waste.net today to learn more. Let us assist you in your efforts to manage your waste. Waste.net may also be able to assist you in finding a market to buy or sell your scrap waste or byproducts.